Okay, let's take a look at this lesson. So we're going to be working on applications. These are, the majority of them, well, all of these are exponential applications. So let's kind of get started on these formulas. First of all, you're not going to have to memorize these formulas. So this is what, I'll just box in the things that I would give you, like on a test. I would give you these. I wouldn't tell you what each of them was for. Like, I'm not going to say which one you use when, but you would have the formulas, so you don't have to memorize the formulas. You would need to know what R and N and all that means. So let's talk about how the formulas are written. First, let's get this notation thing out of the way. So we're going to talk about this notation. We're going to call this notation 1, and let's call this notation 2. These are different kinds of notations. Okay, so let's look at our notations. Sometimes students get really confused about notations. So notation number 1 is called function notation. And what this does, so this is a more formal notation. This, basically, the A in this particular case is names the dependent variable. And in this case, it's a T, names the independent variable. So it actually names them in the notation. This does not mean A times T. It does not mean A times T. Okay, it's just a naming convention. It just lists, like it just says, okay, this function's name is A, and we're going to be using the variable T in it. That's what it says. Okay, the second type 2, I'm just calling this a shorthand notation. This is just shorthand. It's not formal. This A, it basically just names the function. It names the function using the dependent variable. So this is the dependent variable. And this function's name is A. So why would you use one notation versus the other? Well, we need to be comfortable with both, so we're looking at both. But it doesn't really matter. It's what you want to communicate. Do you want to be more formal and you want to communicate A of T, or do you want to just say it's A? It's a choice. Okay, so let's look at the different formulas that we're going to be working with. Let's focus first on growth and decay and look at their similarities and differences. They look almost exactly alike. Notice that the difference for growth, we have a plus, and for decay, we have a minus. That's really the only difference in the formulas. So what do we need to know about it? Well, first of all, we do, A is the initial amount. R is the rate. And this rate needs to be written as a decimal. Okay, it's got to be a decimal. Not a decimal percent, but just a decimal. Okay, and we learned in previous math classes many moons ago how to go from a percent to a decimal. So that's what we would need to do. Time, they're going to, be specific. They'll say it in the prompt, in the word problem. They'll say what the time is. It could be years. It could be hours. It could be anything, right? It could be whatever they say in the problem. And that's growth and decay. So the words we would be looking for, for growth, we might see the word increase. We might see the word appreciate. Things like that, grow. For decay, we're looking for the words, maybe we'll see decrease. Maybe we'll see depreciate. So those would be the kind of words we'd be looking at, in our word problem to see which one to do. Okay, now let's look at these two. These are about money, about compounding interest. And so P stands for the initial principal, the beginning amount of money that you have. R is also, it's a rate, but this is annual. You don't get to pick here. It's just annual. And this has to be a decimal. Again, has to be a decimal, not a decimal percent, a decimal. T is how many years, and N is the number of times per year that the interest is compounded. So in this case that we looked at last time, compound continuously, it has to have the word compound, continuously to use this formula. That's what you're looking for, compound continuously. The other formula is a little bit more, it varies more, because it would tell you that the interest compounds, let's say monthly or, biannually. It'll just use words like that. So let's do some examples. What if the word problem said semi-annually? What would N be? So if they said that, N would be 2, right? Or if they said monthly, compounds monthly, then N would be 12. Okay, so those are just examples. Okay, so the last one that we're going to look at is something called half-life. And we're going to know to use this formula, when it says half-life. It has to use those words, half-life. And half-life, it has a half in the formula. So hopefully if you see half-life, you'll say, oh, that has a half. That's the one I need to use. A is the initial amount of whatever, an element or some compound or something that you have. T is the time that's passed. This could be any amount of time. It could be hours, years, days, it just anything, that could be anything. And N is the half-life of the object. So let's say we have a substance that half-life is, I don't know, let's say it's 100. So the problem says that the half-life is 100 days. Okay, let's say it's the half-life's 100 days. That means that N would be 100. It's not half of 100. Some of my students were getting a little confused and thinking that we're supposed to half that number. No, that is the half-life. What that means is that whatever substance we have, after 100 days, we would only have half of it left. Okay, and so that's the half-life formula. Okay, so we have a couple of examples. You'll need your calculator. We're going to use our calculator to solve these. So the first one, okay, here's our keyword here, guys. It says half-life. So that means we're going to use that half-life formula. Okay, so let's write it down. So the half-life formula is A of T equals little a and 1/2 to the T over N. Okay, there's our little formula. So let's see. Well, we know this is our original amount right here. It's 50 grams. That's what we have to begin with. So then I'm going to replace that A with a 50. Okay, and then we got the half. Time, that's what we don't know. It says how long, so that's going to be a variable. And let's see, N, if we recall, N is the half-life. So N is going to be 64. So we're going to put a 64 here. Let's see, what do we want to have? We want it to decay to 20 grams. So we want it to end up being 20 grams. Okay. So what I do to solve these, which, you can use your solver. I don't have much luck with the solver, but you could try it. I'm going to use the grapher. That's my preference. And so this left side would be the F1. I'm going to put this in F1. The right side, this whole right side would be F2. And the intersection of F1 and F2 is the answer. And it's the X value that's the answer. Okay, it's the X value that's the answer. Okay, so let's move to our calculator, and we're going to put that, in our F1 and F2. So let's go to our calculator. All right, so let's take a look at how we would graph this. Let's add graphs to our document. In F1, we're going to put 20. Okay, so we can't see it, so we're going to have to adjust the screen. We'll do that in just a moment. Let's go back and let's hit the tab button, and then we're going to hit the tab. Come on, you can do it. So tab, okay. There we go. And there's F2, so we'll put in 50 times, got to put that times in there, open parentheses, let's do a fraction, so we'll do the fraction bar, which is 1/2. So let's go ahead and put in a half, and then we're going to go out here and go back to this little palette O math and hit our exponent. That's going to take it to the exponent. Oh, look, we need another fraction there. So let's put a fraction here. Great. And it says T, but we can't use these down here. We can't use the T's down there. Those are just letters. The calculator sees them as letters. We need to use one of these gray. These are variables. So let's put the X in there. Let's use the X. That's the one I would like to use. And then it's over 64. Great. Hit enter. All right, now let's work on the window. We can't really see anything that's going on, so let's go into our window zoom and do our window settings number 1. So let's put our X max at 100. We're just guessing here. Our Y max, I put in 20, so let's go, I don't know, let's go 50. Now let's see if we can see everything. Okay, there we go. We can see it. We just want this intersection. So we do menu, analyze graph, intersection. And now let's highlight that intersection. Great. So we can see our answer, which is the X value is 84.603. And that would be the time. That would be our time in hours. All right, let's take a look at this problem. Let's see, we have $5,000 invested at an annual rate of 16% compounded quarterly. Okay, this right here, compounded quarterly, tells us which formula to use. And quarterly, let's see, quarterly, how many times a year would quarterly be? Let's see, quarterly would be an n equals 4. Okay. Our rate is 16%. Okay, we know that we cannot use percent. We have to use a decimal. And I bet you remember from previous math classes that you move the decimal left twice to turn it into a decimal from a percent. All right, so we have that. That's going to be our R. Okay, great. So let's go ahead and let's fill in all of our blanks. Let's see, let's write down our formula. So our formula is A equals P times 1 plus R over N to the NT. Okay, so let's fill in. See, our original amount is 5,000. So we're going to replace this P with 5,000. Then 1 plus, see, our R is 0.16 and our N is 4. Okay, good. We're raising it to the 4, which is in T. And we want our final amount to be, let's see, 8,000. That's what we want it to be. So we're going to use the same technique as we used before. We're going to put the left side in as F1 in our grapher. And this right side, this whole right side is going to be F2. Okay, so we're going to put those in the graph. And where they intersect is going to be the answer. Remember, the X value of the intersection is the answer. So let's go to our calculator. All right, let's put our, use our graph to answer number 2. So on the left side, we had 8,000. So we'll have F1 is 8,000. Hit enter. And we definitely can't see that, but that's okay. We will get back to it. We'll adjust the window in just a moment. Let's get the equations in first. So to get back up to the equations, hit the tab. See our F2 popped up. So here we want to put 5,000. Then we need the times, right? We have to put the times in there and open our parenthesis. Then we were doing 1 plus, and then we had a fraction. So go over here and insert a fraction. And that was 0.16 over, we decided n was 4. Okay, so we need an exponent here. So we need to go up here and click on our exponent button. And so that takes us to the 4t. Now we need to put 4 times t. Okay, we can't think the calculator is going to figure out to multiply those. We've got to tell it to multiply them. Great, so we have 5,000 times, let's see, 1 plus 0.16 over 4 to the 4x. Okay, great. So let's hit enter. All right, so we totally can't see any of that. So let's go to our menu, our window, and window settings. So we were way up at 8,000. Why don't we put our Y max at, say, oh, I don't know, 10,000. Okay, great. Let's just leave the X max at 10, see if we can see what's going on. So let's just check it out. Okay, great, we got it. This is the intersection that we want. So we go menu, analyze graph, intersection. And so let's highlight the intersection. Great, we see that's 2.9959. Now we don't want to round to 3, we want to go to the thousands, which is 3 decimal places. So we look at the 5 and we see there's a 9 to the right of it. So our answer is going to be 2.996. So it's going to be 2.996.